Hello and welcome part 2 of graph sketching. So last lesson we would have graphed polynomial functions, so hopefully that went okay. Today we're doing the same thing, but we're adding some extra steps ahead of time because we're looking at rational functions. So we will have some vertical asymptotes to deal with, but otherwise the rest is the same. So the steps of graphing rational functions, there's just two kind of pre-steps. The first one is determine the horizontal asymptote. We know how to do that. That was our very first unit back in February. To determine the horizontal asymptote, you have to test the limit of x approaching plus and minus infinity for that function. So I'm not going to go through that again because we did that back in February. So we know how to do limits to positive or negative infinity. Then we have to determine the vertical asymptote. Again, we did that in our second unit. So you have to test the limit of x approaching a from the right and limit of x approaching a from the left. Now what's our a value? Well, you're going to have to look at your starting function. The a value will be anything for which the original function is not defined. So what you're going to do is in the original function, you're going to look to see what kind of values of a would make our denominator 0, and those are the ones we're going to test to see where our vertical asymptote is. And then the rest of the steps are exactly what we did last class. So once you've figured out your horizontal and vertical asymptotes, you make your sign diagram for the first derivative, and that's how you get your min-max values. You make your sign diagram for the second derivative, that's where you get the concavity and inflection points. And then, step number 5 is something different we didn't talk about. You have to look for vertical tangents, if any. So that will come up, I'm not going to do an example now, but that will come up in your assignment. What do I mean by a vertical tangent? That would be where the f prime a is undefined, but it's defined in the original. So I'm going to leave that there for now. That will come up in your assignment. And then the sixth and final step, sketch. Put everything together. Okay, so I've done some of the work already just to save us some time and space here. So the starting function is x squared over x plus 1. So I've already done the asymptotes for you. So first you'd have to test the limit of x approaching infinity for the function, and then the limit of x approaching negative infinity. Now I didn't show my work here, but you should, right? Remember when we learned back in February how we would do our steps to figure that out. So don't take a shortcut like I did, you should be showing your steps. So when you approach positive infinity, when you approach infinity, you get infinity. When you approach negative infinity, you get negative infinity. So based on that, there is no horizontal asymptote. Again, I also did the work for you in part B for the vertical asymptotes. Looking at our original function, our function would be undefined when x is equal to -1. So that's the value we test for our vertical asymptote. You'd have to test the limit of x approaching -1 from the right and the limit of x approaching -1 from the left. And again, I did the work already ahead of time. When you approach it from the right, you get positive infinity. When you approach it from the left, you get negative infinity. So yes, we do have a vertical asymptote at x equals -1. Again, I took a shortcut. You should not. In your work, you should be showing all your steps to show how you got that. I just skipped that to save us time and space on our video lecture. But that should all be reviewed from you from our second unit. Okay, and then the rest is what we've been doing for the last couple of weeks. Now the good news is for curve sketching, the first and second derivative are usually given to you because they're a little bit more complex. So the first derivative is given to us in the question. One thing I should notice though is I can factor out the numerator. So you can factor that to make it easier to make your sign diagram. So based on that we have 3 critical numbers, 0, -2, -1, 0, -2, -1. So I've started my sign diagram. When you take a number larger than your largest key point, like 1,000,000, you would get positive. Now you run through, 0 is odd, so it changes, but 2 is even, so it stays the same, and then that is odd, so that is our sign diagram. So the function is increasing, decreasing, decreasing, increasing. And the other information it gives to us, do we have min or max values? It goes from positive to negative, so that means we'd have a max value here. It's not changing, so that doesn't give us any information. Negative to positive, we have a min here. So we have a min, a max, and it tells us where the graph is increasing and decreasing. Now I'm going to solve for the corresponding y values before I go any further. Again, I've done that work already. Remember when you plug it in, you're going to the original function, not the first derivative. So if I've done it correctly, when x is -2, we get -4. So that means on our graph, we're going to have a max value at -2, -4. Then we test where x is 0, we get 0, so I have a min at 0, 0. Okay, then I can go into the second derivative, and again, that will be given to us in the question, so it saves us some time. Nothing can be factored or simplified. There's only one value for a sign diagram, that would be -1. When we take a large value, larger than the largest key point, like 1,000,000, we would get plus, minus, and that's our sign diagram. This tells us that our graph will be concave down from -infinity to -1. It'll be concave up from -1 to infinity. And we should have an inflection point at x equals -1. Or do we? We actually do not. So remember, we said those would be our candidates, but you have to look. -1 is not defined in the original, so we have no inflection point. Okay, we are ready to put all the pieces together.